So good afternoon, everyone. My name is Tr.KISITU, and I'm here to facilitate you in job 1. So if you're listening, we're starting with photographic interpretation. I guess you have some questions. So can you begin by asking some questions?
You sit there.
Can I have unmute and ask questions if I can start?
Okay.
Can you hear me properly?
Yeah.
Hello, Nasana?
Kindly unmute.
Okay. We're starting now with photographic interpretation.
Facilitation, you want to guess it?
This one.
Yes. So look at that photo. And we're going to look at all the questions that can be asked about photographic interpretation. So the first question they can ask is draw a landscape sketch of the area shown on the photograph. I guess all of you can see that. So now I'm going to illustrate how it can be drawn. Going to illustrate how it can be drawn. Hope you're seeing.
Examine the validity of the recipe.
Can we listen, please? Are you there? So I'm going to take 10 minutes to go through photographic interpretation. Then we go to the other questions. Are you ready, people? Are you ready for the lesson?
Validity put forward to explain the validity of the theory is put forward.
So I'm starting with photographic interpretation. So they can, according to our question, it's draw a landscape sketch of the area shown on the photograph. So if they ask such a question, can you see? Can have our photograph like this. Then something like that. Then we have maybe settlement, you have forest here. So if they tell you to draw a landscape sketch, you begin by looking at the skyline. So you draw, you look at the shape. This is now a rectangle. Then you draw a skyline. Now you indicate whatever they have asked for. So if they send it back and then relief features, you put an upland somewhere there. If they ask for another relief feature, you can put a steep slope. Then you can put a gentle slope. Then you can put a lowland. But if they ask for relief regions, if they ask for physiographic regions, then you put upland area, you put steeply sloping area, you would put gently sloping area, and we put this as low lying. So these are relief features. In case they ask for relief features, these are physiographic regions. In case they ask you to indicate relief features, you put upland, steep slope, gentle slopes, lowland. In case they ask for physiographic regions, you put upland area, steep sloping area, gentle sloping area, low-lying area. So that is it with the drawing. Then the next thing they can ask is describe the relief of the area shown on the photograph. So you begin by looking at the ground. Begin looking at ground, then photograph. You look at the ground and then photograph. For example, if you look at this, let's look at that. Of course, we know very well that this is the background, this is the middle ground, and this is the foreground. So you measure the ground, then the relief. For example, the background is hilly. Then the hilly background has steep slopes. Then the middle ground is gently sloping. Then the foreground is low lying. That's how we describe relief. That's how we describe relief. A moment. Okay, so after describing relief, we're going to look at how they describe relationships. How they describe relationships. So, this is how they describe relationships. We look at land use, relationship. You look at evidence. You look at ground plus reason. So you look at land use, relationship, ground, reason. For example, like we have forestry here, you say forestry is found on steep slopes in the middle ground. The reason is to control soil erosion. If there is forestry on a steep slope, the reason is to control soil erosion. If there is forestry on a gentle slope, the reason is to because of well-drained fertile soils. Then we have, for example, if there was a telephone mast here, you would say telecommunication. The communication is found on the upland in the background. And you give the reason. The reason is a sending of signals. So the land use is telecommunication. The relationship is found. The relief feature is upland, and the reason is for easy sending of signals. Then, if, like, for example, you have settlement around here, you would say settlement is found on the gentle slopes in the middle ground. And the reason is because it is easy to construct. It's easy to construct. In other words, you give a relationship, you give a land use, connect a relationship, measure the slope and give the reason. For example, you have transport. Transport is found, road transport is found on the gentle slope in the middle ground or foreground, and the reason is it's very easy to construct. So we're done with describing relationship. You emphasize land use plus relationship plus ground plus reason. That's how you can pass relationships. So the other question they can ask is about problems. They can ask for problems. They can ask for problems faced by the people living the area where the photograph was taken from. So the problems, you look at the physical features, the features in the photograph. For example, the feature here, you have this upland, you have this forest. So now look at the problems that are related to the highlands. For example, when you're giving your problem, you begin by mentioning the problem. So you put the problem plus why it is a problem plus evidence plus ground. For example, if you look at highlands, you would say landslides, which lead to loss of lives and destruction of property, evidence due to steep slopes in the background. So the problem is landslides, the evidence is steep slopes, and the ground is background. Then you also have soil erosion. How is it a problem? Which leads to loss of soil fertility, evidence due to steep slopes in the background. Which other problem is related to highlands? You can talk about difficult in setting up communication lines, which hinders transport and communication. Evidence due to steep slopes, where in the background. You also have difficult in carrying out mechanized agriculture. Evidence is steep slope, where background. So you look at the problem, how it is a problem, and give evidence from the photograph. Lastly, about photographs, I'm going to talk about the formation. So they can tell you to identify, they can tell you to account for the formation of the feature in the background. So in job 1, you can't talk about something unless you know it. So you begin by identifying the future. So you say the future in the background is, you can say an upland, you can call it a hill, you can call it an iceberg. So you begin by identifying a feature, then identify the process that is associated with its formation. So this one was formed as a result of volcanicity. It gives us the origin due to biochemical. Geochemical means chemicals that are found within the rock, due to geochemical, due to geophysical, and due to radioactivity, decay, which generates intense heat, which lead to the melting of rocks in the mantle into semi-molten state. So that's the origin. Then you say, then molten rock material is intruded in the cracks where it cools and solidifies. So you have to explain how they are formed inside. Then afterwards, you talk about denudation. Then denudational processes of weathering and erosion removes the overlying layers, exposing the solidified material as an upland. So basically, that's what I want to talk about. Photographic interpretation. Basically, that's what I want to talk about. Photographic interpretation. Now you can unmute and ask questions before I go to something else. Can you ask questions before I go to something else? Unmute and ask questions. Can I get a feedback from you people? Hello? Can I continue? I need your feedback before I can continue, people. I'm asking you to unmute, then I get a feedback, then I continue from. Hello? Are you together? Okay, so about that. Okay, we shall get our questions later. Bring that up. So let's send me a message. I sent you questions. Send me a message on the question you want me to start with. Because the questions are so many, we might not be able to complete. So send, I want them to get a feedback from them.
In case you have a question, kindly raise up your hand. Okay, someone is asking, please repeat the part of formation. Repeat the part of formation. You can continue. Okay, in case you have any question on what Teacher Godfrey has been discussing before we dig deep into the presentation, kindly raise up your hands and then you may ask. In case there is any question. Okay. Yes. Okay, Hope Integrated, kindly go on.
Okay.
Thank you, sir. My question is, can you elaborate more on how they award marks on the photographic interpretation? How do they award marks?
Okay. So we have a marginal information, but now we look at the title and the boundary, the flame. Then the accuracy, we look at the features they are calling for. So every feature, they can say physical features, man-made features, so it depends on the question. But basically, that boundary, if it is a square and you draw a rectangle, you not get a mark for the boundary. Then basically the accuracy, a bit of it. No key, we don't have a key for photographic interpretation. Then about the formation, all islands, volcanic plugs, lava plateaus, you use two processes. We use the intrusive volcanicity, talk about the intrusive volcanicity, which is the intrusion of molten material into the layers of the Earth's crust. Then after talking about that, you have to bring in denudation, which exposes those rocks that solidified inside. But when you're starting, you begin by identifying the feature. If they say, account for the formation of the feature in the photograph, what you do, begin by identifying the feature. Don't say the feature in the photograph was formed as a result. You will not get an end mark. So identify the feature, then identify the process that is associated with its formation. So the process is volcanicity. Briefly give us about its origin, where we bring in the geochemical, rocks, rock chemicals reacting. Then you talk about the geophysical, rocks can rub, compression from overlying rocks. Then you talk about radioactivity decay, which lead to the melting of rocks in the mantle into, say, molten state. Then when the rocks melt, due to the differences in pressure between the Earth's interior and the Earth's crust, you have intrusion of magma into the layers of the Earth's crust, where it cools and solidifies. And then later, the industrial process of erosion weathering removes the overlying layers, and it is exposed as a highland. I guess I've answered your question. I want to go to the question now. So let them choose the question they want. Ask them. So you can choose the question of your choice. There are so many questions, I can't discuss them today, but you can ask, you can put up your hand and you tell me the question you want me to ask. You have all the questions. Hello? It is a landscape sketch, not a land scale. It's a landscape sketch. So don't call it a land scale. So, okay, let's start with examine the validity of the theories put forward to explain the formation of the East African Rift Valley. I think they taught you something about faulting. So this topic is under faulting. Now, since the topic is under faulting, you need to know the definition of faulting. And make sure in that definition, you have breaking, cracking, disintegration of rocks. And in that process, you must have the element of displacement. So if you just define and end at this breaking of rocks, that's not faulting. So in your definition, make sure you involve breaking of rocks and then as well as their displacement along the same line of fracture. So in your definition, make sure you involve breaking of rocks, breaking disintegration of rocks, breaking disintegration of rocks, as well as their displacement. So make sure you ensure that you know that definition. But now, how do we start the question? So let's go to the approach to the question. Now, if they say examine the validity of the theories, you begin by defining a Rift Valley as an elongated depression, elongated narrow, flat flat depression bordered by in-facing steep slopes on either side. So after defining, give us examples of the Rift Valley we have in East Africa. Of course, you know you have the Eastern Arm and the Western Arm. Those ones you have in your notes. Then identify the process that is associated with the formation of the Rift Valley. So you said the Rift Valley was formed as a result of faulting. Define faulting as the fracturing, breaking of the Earth's crust due to tectonic forces of compression, tension, etc., and then as well as their displacement. So in the definition, you have to have those two elements, breaking down of rocks and their displacement, which displacement can be either vertical or horizontal. Then automatically you give us the origin of, faulting. Like I told you, talk about the geophysical, the geochemical, the radioactivity, which lead to the generation of heat in the mantle, which lead to the melting of rocks in the mantle into same molten state. Then you talk about diverging convective currents. When they boil, they create tensional forces. Then when they boil converging, they create compressional forces. When they try to rise, they create differential uplift. And when they sink back in the center, they create relative sinking. Then after that, you point out that there are many theories that led to the formation of the East African Rift Valley. Now, at the end of every theory, make sure you criticize, you support, you give the validity and support. That's what they're after. So you explain the theory very well, then criticize and support. So when they say examine the validity of the theories, state the theory very well, draw the diagrams, then support by giving the validity, then give its weakness. So you know very well that the first theory is the tensional force theory, put forward by Gregory, and he talked about the Earth's crust being exposed to tensional forces. So you have the diverging convective currents leading to tensional forces, which act on layers of the Earth's crust, leading to development of normal faults. And land is divided into 3 crustal blocks, the middle block and the 2 outer blocks. Then further action by tensional forces lead to the sinking of the middle block, which forms a Rift Valley. Then after explaining that theory, try to criticize it, try to support it by saying that geological surveys in Kenya and Uganda have also revealed that rift faults are normal. So because they are slanting in a V shape, so the surveys that have been carried out portray the V shape of the Rift Valley. So that shows that the Rift Valley was formed as a result of tensional forces. However, there are those ones who criticize and they say that if you look at the scarps, they are not uniform in height, suggesting that it was not similar in the mode of formation that was experienced. So there were some differences in the formation. So you can't say it was formed as a result of, it was not formed, you can't say it was formed as a result of normal faulting, when actually in some cases you have a V shape, then in other cases you have U shape. So that shows that it is criticized. Then when you're done with that, you go to another theory, which is compressional force theory. Of course, that one is associated with the converging convective currents, which lead to compression forces, which act on layers of the Earth's crust, leading to development of reversed fault. And land is divided into 3 blocks. Then further action by compression forces forces the 2 outer blocks to override the center block. And then when they override, the overhanging sides are worn down by erosion to create an open Rift Valley. Then, of course, that theory, if you look at it, you see that it has been disapproved on ground that the deep boreholes sunk into the Rift Valley floor are slanting. And this proves that the Rift Valley was formed due to tensional forces. So they are saying that those people who try to dig the borehole, they say that if you look, they look in the Rift Valley floor, they find that it is kind of slanting. So they criticize this theory, which says that it is supposed to be the 2 outer blocks overrode the middle block. Then we go to differential uplift. Now this is caused by rising convection currents, which lead to multiple faults, and land is uplifted at different rates. But now the middle block, the 2 outer blocks are uplifted faster than the middle block. So the middle block forms the Rift Valley. So, and it is supported by saying that presence of fault steps at the Rift Valley flow indicates the occurrence of differential uplift. So it is supported because if you look at the Rift Valley flow, there are those steps, the fault steps, indicating that land was uplifted, where the middle block was uplifted at a slower rate as compared to the 2 outer blocks. Then you go to up-arching theory. This was advanced by L.C. King, and he says that the Rift Valley resulted from a powerful up-arching. Land up-arched. It like folded upwards like this. And this happened in Central Africa. And due to overarching, a crack developed and erosion took place on that crack, and it widened from a Rift Valley. So how is this relevant? They say Rift Valley are relatively raised and have fault scarps illustrating the uplift. So that uplift, it happened as land folded upwards. So the occurrence of a central basin of Victoria and Choga separate the rift. These 2 depressions separate the 2 Rift Valley, indicating that maybe there was a crack and land was eroded and a Rift Valley was formed. Then plate tectonism. Of course, you know very well seafloor spreading as the material gets out of the mid-ocean ridge. It pushes the continents away, widening and forming a Rift Valley. And this theory is supported by the widening of the East African Rift Valley at a rate of 2 centimeters per year. The other theory is of relative sinking. Of course, this was caused by the sinking convectional currents. It happens when the currents rise and then they sink back. But now when they sink, they create numerous faults, and then land starts sinking downwards. But as it sinks downwards, the middle block sinks faster than the outer blocks, and that one forms a Rift Valley. So since the questions are so many, I think you can have some questions. Then we continue. Oh.
Any questions? You can raise up the hand.
Questions? Okay. So we're going to look at another question. Which is examine the relationship between the nature of material ejected and the resultant landforms in East Africa. Examine the relationship between the nature of material ejected and the resultant landforms in East Africa. So basically that question is about extrusive volcanicity because it talks about ejection of materials. But now I told you numbers to do with tectonic forces or earth movements. They require you to define. Then after defining, you give the origin. Then after giving the origin, you have to identify, clearly state out the material that is ejected out. So you begin by defining extrusive volcanicity as a process through which molten material, gases from the Earth's mantle are forcefully extruded onto the Earth's surface. So they come out onto the Earth's surface. And once that material, if it is still inside, it is called lava, it is called magma. But once it is extruded onto the Earth's surface, it changes the name to lava. So after that, you give us the origin of volcanicity. Of course, you talk about the intense heat. The intense heat originates from the geochemical, geophysical, radioactivity. Of course, when we say geophysical, it implies friction caused by overlying layers, caused by rocks rubbing against themselves. When we talk about geochemical, we mean the chemicals within the rocks reacting. When we talk about radioactivity decay, we talk about decaying of some mineral elements and they generate heat. So after generating heat, of course, it is the melting of rocks in the mantle into same molten state. When those rocks melt, then they develop what we call convective currents. After melting, they start boiling, like the way porridge boils. So they boil, but on large scale. That's what we mean by generation of convective currents. Now, due to the existence of cracks, that material is forced to move from the Earth's upper mantle through those cracks or fissures or veins until when it reaches the Earth's crust. Now, we're going to look at the nature of material that is the nature of material that is extruded onto the Earth's surface, because it is very important. We're going to use it in the explanation of this question. So we have liquid materials. Now the liquid materials, we have three. You have acidic lava or andesitic lava. In fact, if you get this, you'll even be able to answer questions which say, a question which says, distinguish between acidic lava and basic lava. You need this information. So, of course, this has a high silica content of about 66%, and it melts at a high temperature. It is highly viscous, meaning it is sticky. It's very sticky and thick. Then the eruptions by this kind of acidic lava are less frequent, and it cools very fast. So it solidifies and cools very fast. Then the second liquid material we have is the basic lava. This one is of low silica content of between 45 to 52%, and it is rich in magnesium and iron. This one is fluid and is able to flow for a long distance before solidifying. So it is ever at a high temperature of about 1,200 degrees Celsius and takes a long time to cool down. Then you also have intermediate lava. This one is of moderate silica content and is fairly viscous. So, and all these three determine the nature of landforms that are formed. Where you have acidic lava, it is associated with the formation of very steep landforms. Where you have basic lava, it is associated with formation of landforms with gentle slopes. Then apart from the lipid material, you also have gaseous materials. It is composed of dissolved gaseous compounds which are emitted during eruption. For example, sulfur, nitrogen, chlorine, hydrogen, etc. And this accounts for the formation of explosion craters, as we shall see. Then you also have soily materials like cinder, ash, pyroclasts. They also come out, and these ones also account for the formation of ash and cinder cones. We shall look at that. Now, besides the nature of the material, you also have other things to consider when you're explaining those points. So as you're explaining, make sure you mention the type of material that is erupted. You mention the nature of eruption. You have to talk about, is it a violent? Of course, violent eruption is associated with acidic lava. Then you also talk about is it effusive or silent? Effusive eruption is associated with basic lava. Then you also need to tell us the nature of passage, where the material passes. Usually, acidic lava is associated with veins. So you talk about the veins in the explanation of the formation of those landforms. Then you also talk about the fissures. Usually, basic lava is associated with fissures, where the material gets out and spreads for a long period of time. Then you also talk about the number of eruptions. For example, we shall talk about during the formation of a volcanic cone. We have successive eruptions, successive violent eruption of acidic and intermediate lava. So it happens over and over successfully. Then you should also talk about the quantity of material ejected. So in that question, you have to emphasize the material and landforms that are formed. So now, when you're answering, the standard is you identify the landform, for example, a composite volcano. Then you describe that landform. Then you explain how it is formed. Then after explaining how it is formed, you give examples. Then you illustrate. So when you're talking about a composite volcano, you talk about it by describing it as a large steep-sided volcanic cones. In paper one, when they say cones, domes, they mean mountains. So these are large steep-sided volcanic cones, and they're made up of alternating layers of ash and lava. And they're built over a long period of time through successive eruption and pouring out of large quantities of acidic and intermediate lava. So when you're emphasizing the formation, I talked about nature of eruption. Which is, of course, successive eruption. Quantity of material erupted, large quantities. Nature of material, acidic and intermediate lava from the Earth's interior. So they pile over a long period of time. After piling, a composite volcano is not complete until when it has a volcano on top of a mountain. So you say later eruption blows off a volcanic top to create a crater. Then you also have to account for those subsidiary cones. So you tell us that sometimes the eruption can happen and pressure, it reaches an extent that where pressure cannot push the material over the top of a mountain. So subsidiary vents are formed in the sides of a mountain, and they will lead to the formation of a subsidiary cones. Give us examples: Mount Muhavula, Long Knot, illustrate, and you have the marks. So don't just run away from the landform. Each landform carries marks. So don't just define and go with you identify composite volcano. Describe, explain how it was formed, account for the formation of a volcano on top, talk about the parasitic cones, then give us examples, then got something. Now we have two types of composite volcanoes. We have a simple volcano with a single vent, and then a composite volcano with more than one vent. So you can talk about that. Then you go to the next landform, which is ash and cinder cones. Now, ash and cinder cones, I told you begin by describing. So when they are marking, you identify ash and cinder cones. You describe, these are small symmetrical cones of pyroclasts with fairly steep sides and a large crater at the top. How are they formed? Now, remember in your formation, make sure you involve the nature of material, the nature of eruption. So these are formed by a single eruption, meaning unlike a composite volcano where you have successive eruption, this one happens once. So formation, we have a single explosive eruption of acidic lava from a vent. Nature of passage, vent. Number of eruption, single. Nature of eruption, explosive. Nature of material, acidic lava. And it is blown out violently into air. So the material gets out of the ground into air, then it comes back and it piles around the vent. So to form an ash and cinder cones. So you give us examples. You have Teleki, Lakiu, Chiuru, etc. Then illustrate. So as they are marking, they mark you identify, you describe, explain how it was formed, give examples, illustrate. Then we go to the next one, which is a basalt dome. It's also called a shield volcano. It's also called a lava dome, sorry. So describe a broad-based low-lying flat-topped volcano of basic lava with the gently sloping sides. Of course, you also have to mention that sometimes it has a shallow, steep-sided, sunken crater at the top. How was it formed? Nature of eruption, silent eruption, effusive eruption. Nature of material, basic lava. So, effusive eruption of basic lava. Nature of passage, through numerous fissures. So the material gets out silently through fissures. And because it is basic, it is able to flow for a long distance before solidifying. And they form a wide cone. So how are we relating nature of material and nature of landforms? We're talking about a basic lava with gently sloping sides. And it is formed by effusive eruption of basic lava through fissures, which is able to flow for a long distance before solidifying to form a wide volcanic cone or dome or mountain. So you give us examples. For example, you have Tukuyu, Inirungwe, ranges of southern Tanzania, Masabit, etc. So when you're done with that, make sure you get the illustrations. And when you're drawing these illustrations, make sure you draw with gentle slopes. Don't draw basalt dome with steep slopes. Then we go to the next one, which is a lava plateau. A lava plateau, of course, you also lava plateau or lava plain or basalt dome or basalt sheet. So this is an extensive, fairly raised landform with generally leveled summit made up of successive layers of basic lava. So you look at now, how do we give the relationship between nature of material and landform? How are they formed? They are formed when large quantities. So now we are bringing the issue of quantity, large quantities of basic lava. So the nature of lava is basic. Are quietly ejected. So nature of eruption is effusive eruption. Nature of passage through several or numerous fissures. And because it is basic, it gets out and flows for a long distance before solidifying. So it doesn't happen once. The eruption can take place and the first layer is formed, Then another eruption happens and another layer is formed. That's why we say successive lava flows from repeated eruption results into accumulation of lava to higher levels, forming a lava plain. Then you give examples, then you illustrate. Then you go to a tumulodome. A tumulodome, of course, this is a steep-sided convex dome of acidic or intermediate lava. Now, this one is steep-sided. And because it is steep-sided, it is associated with acidic lava. Now, how was it formed? Nature of eruption, you talk about viscous lava. Viscous means very sticky, very thick, is extruded. It is extruded and it piles around the vent. And because acidic lava is known for cooling very fast, the outer part cools very fast, while the inner part remains fluid. Now, what happens when another eruption occurs? The outer part will widen as new material enters into the center of that round kind of dome, and to keep growing bigger and bigger and bigger to form a tumulodome. So how are they formed? They are formed by eruption of acidic lava around the vent, where it hardens very fast, blocking away the remaining lava from flowing outside. Then it cools, and the coating is on top. Inside, it remains fluid. Then the material keeps coming from down due to later eruptions, and then it keeps widening and widening and widening. Now, if it happens to form in a crater, it forms what we call a thyroid. So you give examples, draw illustrations, and then that one is done. Then we go to a volcanic neck or volcanic plug. So still, you need to know how to describe a steep cylindrical volcanic landform of bare rocks. How is it formed? You have to involve the nature of material and the passage of that material. So nature of material ejected is acidic lava. It's not ejected, it is. Now, what happens during the formation of a volcanic mountain? The material comes out and solidifies within the vent. But this material which solidifies within the vent, you have to mention, because we're talking about the relationship between nature of material and the resultant landform. So you talk about the material which gets out of the vent, which is acidic. So it solidifies around the vent. Then the overlying layers are removed by the denudation forces, erosion, weathering. Now that hardened part which solidified within the vent is exposed as a volcanic neck. Then you give examples, Mawenzi on Mount Kilimanjaro, Toro Rock. Then you illustrate, make sure you illustrate. Then you go to a plug dome. So a plug dome, unlike a volcanic neck where the material solidifies within the vent, this one, the material is extruded out violently as a rigid cylindrical mass. Like if you look at the shape of an eggplant, the blue eggplant, the way it looks. So the material comes out in that shape amidst hot air and gases. So nature of eruption, violent eruption of extremely thick acidic lava through the vent. And when it gets out, it is unable to flow for a long distance. So it solidifies immediately and blocks the vent to form a steep-sided landform. Examples can be seen at Central Tower and Fisher's Tower, both in Hell's Gate National Park near Naivasha in Kenya. So when you're done with that, you go to another landform, which is an explosion crater or ring crater or Mars. Now, this one, you don't mention lava anywhere. So you begin by identifying explosion crater. Then you describe a small, shallow, flat-floored circular depression surrounded by a low rim of pyroclasts and local rocks, usually of less than 50 meters deep and 500 meters wide. Now, how are they formed? Now here, you say they are formed when layers of Earth's crust are blown off by a series of gaseous of violent eruption, creating a depression known as a crater. So the gases come from the ground and they build pressure, which pushes off the country rocks. And they push those rocks in the air and they follow back as layers of pyroclasts. Then you give us examples, Katwe, Nyungu. Now, because we're talking about depressions, don't give them as lakes. We're giving them as depressions. That's why you're saying Katwe, Nyungu. Don't say Lake Katwe, Lake Nyungu. You're talking about depressions. We're interested in landforms, not drainage features. That's why you're not saying there, you're not seeing there Lake Katwe. Then you go to caldera. You define as a large, deep, steep-sided circular depression of more than 1 kilometer wide, resulting from the destruction of the upper part of the volcano in a violent eruption. Now, two theories were put forward to explain the formation of a caldera. The first one is you have, after the formation of the main mountain, lava solidifies within the vent. Then subsequent eruption leads to the blowing off of the upper part of a volcano to form a wide deep crater, which is now a caldera. Or alternatively, there is a theory of cauldron subsidence where the weight of a volcanic top sinks within a chasm or the empty vent left by the vent. So it can sink within the vent to create a crater, which we call, to create a big crater, which we call a caldera. So examples are Ngonzi, Ngorongoro. They are not, in those depressions, there are lakes, but we're not interested in lakes. We're interested in depression. That's why I'm mentioning Ngorongoro, Ngonzi, etc. Then you have a lava-dammed lake depression. I'm not talking about a lava-dammed lake because they're interested in landforms. But if they're interested in features, then you talk about lava. If they say, account for the formation of, examine the influence of extrusive volcanicity on the formation of, and on the formation of different features, they bring in even the drainage features. But if they are specific on landforms, then you don't talk about those drainage features. So lava-dammed lake depressions, these are depressions that are occupied by lava-dammed lakes. So, and they are formed by blockage of river valleys by lava. So how are they formed? They are formed when lava is erupted from a mountain and it dams a river valley. So in this one, sometimes water can point backwards to form that. So I need questions before I go to another question. So the diagrams, yes, and make sure you draw talking diagrams. Don't just read diagram without any labeling. For example, like you see that one, it has lava flows, block the valley, then lava down the lakes. But make sure you do that at a very fast speed. Yes, theories try to be very fast. You have to work very hard and work very fast. So unless you have another question, unmute and go to the next question now. Next one. Okay. So we're going to look at another question now. I'm very fast.
You already asked.
Yeah, on the diagram of the uplift, are we supposed to break this how you have shown it, or it is supposed to face on the other sides? The central block should be up or down?
Okay, now because we're talking about the Rift Valley, the central part is supposed to be down, but if you're talking about block mountains, it would be up. Is that clear? Is that clear? Okay. Is that clear? Okay, let's go to the next question.
Yes.
Okay. Okay, okay, that question, you explain the formation of those landforms, then you bring other factors. And the other factors, you just mentioned them. For example, nature of passage. Are we together? We've talked about nature of passage. I think I outlined them in that. Let me show you where I outlined them from. So these are the other factors now. Nature of eruption, nature of passage, number of eruption, quantity of material. So you explain your landform very well, then you bring these ones as by the you just mentioned. However, there are other factors. Then you explain nature of eruption, nature of passage, like that. Okay. Maybe about drainage landforms, they can ask you a question. Examine the influence of extrusive volcanicity on the drainage of East Africa. You can write that one down. I didn't put it down. Examine the influence of volcanicity on the formation of drainage landforms of East Africa. So you of course you define volcanicity, give the origin of volcanicity. Then when you're done with that, you talk about the drainage features now. You explain how they are formed. Now, we shall talk about, now not caldera, we shall be talking about caldera lake. And then you describe how a depression is formed when it is filled with the water. Then you talk about crater lakes. Explain how it is formed. Then when it is filled with the water, talk about lava dammed lakes. Talk about arena lakes. Those ones that are formed in, arenas. We shall look at them. We shall look at those depressions. Then you talk about volcanicity leading to the formation of mountains, which mountains led to the radial drainage patterns. Radial drainage pattern is when you have rivers originating from mountains. For example, you have River Manafa, River Sipi, River Porogoma, all originating from Mount Elgon. You also talk about volcanicity leading to the formation of a waterfall, especially where the river flows over the edge of a sill, or where the river flows over a hard-resistant dike. Then so you talk about the drainage features to do with the water bodies. You look at limited surface drainage where you have volcanic rocks, for example, in Kisoro. So you talk about you talk about drainage features only. So when they say drainage, talk about only drainage features. Unless you have another question, we can continue. If you have I've given a chance for one question, then I go to another question. Then any other question? Can we continue? Okay. Let's continue now. So I'm going to look at another question. So we're going to look at this question of intrusive volcanicity. Examine the influence of intrusive volcanicity on the development of relief landforms in East Africa. Examine the influence of intrusive volcanicity on the development of relief landforms in East Africa. So when they say intrusive volcanicity, you talk about intrusive volcanicity only. So you're going to define intrusive volcanicity. Then after defining intrusive volcanicity, you're going to talk about the origin of intrusive volcanicity. Then after talking about the origin of intrusive volcanicity, you'll tell us the formation of various features resulting from intrusive volcanicity. So intrusive volcanicity, of course, you talk about the injection and solidification of magma underneath the Earth's crust or into the Earth's crust. Don't say onto. This one happens inside. That's why we say underneath or into the layers of the Earth's crust. Now, after telling us that, you say that intrusive features have effects only when they are exposed onto the Earth's surface due to prolonged period of denudation forces of weathering, erosion, and mass wasting. So now, if you're explaining the formation of intrusive features, you have to explain how they are formed inside and then what happens when they're exposed on the Earth's surface. So if you only talk about when they're inside, then you don't get marks. So now the formation of these features depend on the relative resistance of the rock and the forces of weathering and erosion. So the formation of the resultant features after exposure depend on the nature of the relative resistance. If the rocks are soft, what forms are usually depressions. If the rocks are hard, what forms are usually highlands. So the formation of intrusive features depend on the following. First of all, it depends on the structure of the rocks. So you have to point out these ones. So, for example, sometimes magma flows through cracks that are across the bedding planes or along the bedding planes. For example, during the formation of the seal, magma either is intruded vertically or horizontally. That's why you have to mention these factors which influence the formation of the features. So structure of the rock, other layers, do we have horizontal bedding planes or vertical bedding planes where magma can either be intruded vertically or horizontally? Then you talk about the nature of magma intruded. Is it highly viscous or is it basic? So after talking about that, then we go to the landforms. Now you see that I drew two landforms. One landform, and when you're drawing, make sure you put there before denudation. And then you say after denudation. So in Jog 1, you begin by identifying the feature. The feature is a bathory. Define it as a large dome-shaped mass of granitic rocks formed at great depth by large-scale intrusion of acidic magma that cools and solidifies slowly. So you have to mention that the large-scale intrusion of acidic magma that cools and solidifies at great depth. So you explain how it is formed inside. Now you go to the second statement. Now in this, if you look at this, you're going to find that every landform, don't just run away. One landform can even earn you between 3 to 4 marks. So don't just run away for the sake of running away. So the first ticking is put, the first tick can go to the identification. Then you look at the description. Then formation, formed by large-scale intrusion of acidic lava that cools and solidifies slowly. Then tell us what happens when the material, when denudation takes place, when the layers are removed by weathering, erosion. So when the layers are removed, what happens? If it is made up of a hard resistant rock, it will come out as an inselberg, or these hills in Mubende, the hills you see in Mubende. Are you together? Then if it is made up of soft rocks, what happens? When it is exposed, it will form what we call an arena because the rocks are weak. So it will form a depression which we call an arena. Hope you're seeing it. Then you go to dikes. Now you define a dike as vertical or wall-like or steeply inclined igneous rocks, rock structure cutting across the country rocks or the layers of sedimentary rocks. Then when you're done, you explain how they are formed inside. They are formed when magma is intruded and solidifies into igneous rock structure, almost vertically along the vertical fissures or lines of weakness. Then you explain what happens when denudation sets in. Of course, if denudation sets in of weathering and erosion, and the dikes are exposed and they are resistant, they form what we call narrow. When they form ridges, if they are made up of resistant rocks, then if they are subjected to weathering and they are made up of soft rocks, they form trenches. Then when you're done with that, you give us examples and you illustrate. So you're seeing my line there after drawing, you're seeing this line where I've put when it is dotted. It shows that it was, the denudation took place and the ridges were exposed. Now one hill is standing outside. That is a ridge. Another one is, there's a depression, which is a trench. Then we go to a sill. A sill, these are tabular sheets of igneous rocks lying horizontally between the bedding planes of the rock strata. So it is horizontal, like you see a table where you're seated. Explain how they are formed. They are formed when magma is intruded and spreads horizontally. So the magma goes in along the bedding planes. It solidifies between the bedding planes of the rock layers or strata. So they vary in thicknesses and they may extend for several kilometers. Now, how are they formed? When the overlying rocks are removed and the sills are made up of hard resistant rocks, they form flat-topped hills. They form flat-topped hills. Then we go to laccolith. A laccolith is like a dome, a hill, and the material is intruded in the layers. Then when it comes and piles, the overlying layers arch upwards and forms that shape. So it is formed by large-scale intrusion of viscous acidic magma into local layers, which is unable to spread for a long distance and accumulates in large mass, arching up the overlying rocks. So if they are made up of hard resistant rocks, denudation process of erosion will erode the overlying layers and uplands will be formed. Don't forget to give the examples. Then you also have ring dikes. Now these ones are ring-like intrusion of igneous rocks. They are formed when circular blocks sink within the interior, and then material, as they sink, magma tends to, they sink in magma and magma forms those rings around them. Now, when magma solidifies, it solidifies with those rings around those blocks. When they're exposed, you can easily see those rings around the blocks. And then lastly, a lapolith. This is like a source. This forms along when magma is intruded along the layers, the horizontal layers. And because of too much weight, it is forced to sink inside. Then when the overlying layers are removed, we shall have the formation of that depression. So basically, when you're dealing with this, you explain how landform, you do like 4 things. Explain, identify, describe, explain how the material is formed inside. Then what happens when the denudation processes come in and the rocks are resistant. Then what happens when the denudation processes come in when the rocks are resistant. So, excuse me. So the question is done. I need questions before I go to another question. Okay, Hussein, budget your time very well. But if you're caught up with time, at least identify the landform, describe it, but make sure you explain how it is formed inside and outside. But don't talk about time. Time is always there. Just be very fast You can practice on how to deal with time issues by writing an essay with diagrams. Yes, the drainage, no, we don't have drainage landforms. We have drainage. Drainage is drainage, and landforms are landforms. When they ask for landforms, don't talk about drainage. But they can, when they say features, then you talk about all the features, including the drainage features. So ask 2 more questions, then we go to another question.
You can raise up your hands, those who have questions.
Okay. So let's go to another question. Okay. Let's go to another question. So they can ask you this question: account for the growth and distribution of alpine vegetation. So when they say alpine vegetation, it's the same as mountain vegetation. Unfortunately, some teachers confuse these numbers with altitude and relief. So make sure you be clear there. Alpine vegetation only starts at an altitude of 3,000 meters above sea level. So we talk about bamboo, heath and moorland, and temperate. Period. We talk about those ones only. You don't bring in other issues. So how do we attempt this question? You begin by defining alpine vegetation. So you change that. You begin by defining alpine vegetation. So you begin by defining alpine vegetation, not natural vegetation. So this is a type of natural vegetation that only grows in cool highland areas of East Africa, mainly above the altitude of 3,000 meters above sea level. So we have only 3 types of vegetation which follow under this category. So make sure you emphasize that. And it can only be traced on 3 mountains in East Africa. That is Mount Rwenzori, Mount Elgon, and Mount Kenya. So the examples, we have alpine, bamboo. We have the examples of alpine, we have bamboo, heath, we have temperate, heath, and moorland. Now, when you're explaining this question, you begin by telling us, you start the first vegetation you see between the and you have to put it clearly that between the altitude of 2,500 to 3,000 meters above sea level, especially on Mount Rwenzori, Elgon, and Kenya, we have temperate forests. Give us their characteristics. And as you give the characteristics, make sure you attach the reason. So at that height, we have temperate forests. And you tell us that they're characterized by the following characteristics. They have tall trees with small straight trunks and small branches. Why? Due to cool temperatures of below 10 degrees Celsius. Then you also tell us that they're evergreen and they don't shed off their leaves. Why? The temperatures are very cool and the soils are of moderate fertility, so they favor them to be evergreen. Then the trees are conical shaped. So the trees are of softwood. Due to low humidity and cool temperatures, they have small, sharp, pointed leaves due to cool temperatures. Then they grow in pure stands. So you give us those characteristics. When you're done with those characteristics, you give the factors for that particular vegetation type. So cool temperatures of about 10 degrees Celsius due to high altitude, making the trees to remain evergreen. So integrate the characteristics at the end of every factor. So after the cool temperatures account for evergreen tree species. Moderate rainfall of about 1,000 millimeters per annum, which is evenly distributed throughout the year, facilitate the growth of slightly tall trees. Try to integrate the characteristics. Then the relatively low humidity and shallow soils lead to the growth of slightly shorter trees. Then the steep slopes with the thin soils along the mountains support the growth of lighty trees. Then favorable government policies lead to the conservation of temporary forests on those mountains. Then lastly, limited managed activities in terms of cultivation, lumbering, etc., lead to the growth of this. When you're done with that, then you go to another height. You go to another height. So beyond the other height, that is between 3,500 to 4,000 meters above sea level, we have the bamboo forest. You know bamboo, the Bagisukoliti malewa, those yellowish things which are found on top of mountains. Now these ones, like they look like sugarcane and they have those nodes and internodes. So if you look at them, they exist. If you go on top of those mountains, you find them there at a height of 3,500 to 4,000 meters above sea level. You also give us their characteristics. They have hollow segmented stems due to little rainfall and low humidity. They have sharp pointed leaves to reduce on the rate of water consumption, because there the moisture rate is so low because of high altitude. Then they have small soft branches due to cold temperatures. The stems appear yellowish. That is an adaptation to limited light. So they were given that color to adapt it to those light. Then you look at, they grow in pure stands. You see only one tree species occurring in pure stands. Then the trees have prop roots, those roots which extend from the branch of the trees downwards. Then you give us the conditions for the growth of bamboo forests. Of course, cold temperatures, leading the growth of trees that are evergreen, little rainfall. At that height, rainfall received is very little. That's why the trees have smaller nodes. Then you also have little thin skeletal soils. The soils are so infertile. And because they are so infertile, they can't support the growth of big trees, but rather light trees. Then high altitude lead to very cool temperatures, which favor the growth of those trees. Then supportive government policy, which lead to the conservation of bamboo forests. Then lastly, limited managed activity, which favor the existence of this kind of vegetation. Then lastly, the last vegetation type, which is above 4,000, because from 4,000 upwards, we have bare rock and snow. So at that point, we have now there are more of flowers. There are more of flowers, and they are found at that height. And they are composed of flowers, mosses, ferns, due to limited rainfall, but with other forms of precipitation. There is some bit of snow, which snow enhances their growth. Then you have the trees appear very short and tufted. They are too short because rainfall at that height is very limited. There's more of snow and what. Then the main tree species, we have lobelia, giant heathers, and ground shells. Then you look at, I'm very fast because I want to cover some questions. I'm sorry about that. If I be slow, but we're going to have these notes from the, you'll access the notes, so don't get worried. But I wanted to go through so many questions. That's why I'm a bit fast. But if I was too slow, you would only look at 3 questions and we would end there. So then the factors, very cold temperatures of 5 degrees, between 5 degrees to 10 degrees, and of very high altitude, which do not support the growth of big trees. Then very little rainfall, but with increased other forms of precipitation, like snow, fog, which limit the growth of trees, but grasses. Then very low humidity due to cool temperatures, which do not support the growth of luxuriant trees, but giant heathers. Then limited managed interference, and the question is done. So can I look at questions? Now, someone is asking, if you're doing a number on intrusive landforms and you don't show denudation, then you not get marks. I've told you those features are not landforms unless they're exposed. unless they are exposed by denudation processes. If they're not exposed, you not get marks. So you have to explain how they're formed inside, then what happens after exposure. Now, can I get questions before I can continue? I need more questions on that. You can raise your hands if you have a question. Okay, so let me continue. The other question we are going to look at is account for the growth and distribution of mangrove vegetation in East Africa. Account for the growth and distribution of mangrove vegetation in East Africa. So basically, you just locate, give the characteristics of mangrove vegetation, give the factors, and the question is done. So, but as you're giving the characteristics, try to attach the reason. Attach the reason. Let me first look at this question. Are conditions given? No. This is just a direct question. The two sides come in when they are asking for vegetation distribution. But if but if it is mountain, just tell us, why do we have this vegetation? Yes, Gilbert. Gilbert, ask your question. Okay, Mediterranean vegetation. That one, if they ask about Mediterranean vegetation, locate where Mediterranean vegetation is located. Describe the characteristics. Now, if you want to learn the characteristics, mention trees, plants, grass. Are you together? So if you go there, you talk about the tree species there, you talk about the grass. So that's why we say grass. The grass is like this. The trees are like this. You get, then you give the factors. If I get time, I'll look at it. If I get time, I'll look at it. I think there are no more questions. Let me go to the next question. The Mediterranean mangrove vegetation. Of course, this kind of vegetation is found along the coast of East Africa. It's found along the coast of East Africa. And that's what we write. It occurs at the coast of East Africa between 5 degrees north and south of the equator. So you have to locate it using longitudes and latitudes. Then when you're done locating it using longitudes and latitudes, you tell us the areas where it is found. Of course, it is common at Mombasa, Dar es Salaam, Tanga. So you mention those areas and lower river valleys of Rufiji and Ruvuma. Then you also note that they grow in swampy areas where mud is deposited in mud flats, and they grow best in salty waters at high tides. So you have to go an extra mile and tell us where it grows. Now we want a full page of characteristics. Whether they have asked for, in fact, numbers of vegetation, even if they say account for the growth and distribution of tropical rainforest. Before you explain the factors, talk about the characteristics. And at the end of every characteristic, please give a reason, attach a reason. Attach a reason. Then when you're done with the characteristics, write a statement to show that you're now going for the factors. No, Mount Elgon is not a glaciated mountain, but because it is a high mountain, it experiences cold conditions, which favor the growth of the vegetation. The glaciated mountains, we have Kilimanjaro, Rwenzori, and which other one? So, but Elgon is not part of those mountains. Okay, Now, the trees are evergreen. If you look at the trees, they're evergreen. And the reason as to why they're evergreen is due to heavy rainfall and adequate water supply by wave erosion. Because they are near the coast, there is a lot of flooding. So they tend to receive ample water supply, which ample water supply helps to favor their greenness. Then the trees have broad leaves. And why do they have broad leaves? They need to trap adequate sunlight for photosynthesis. And they also need to get rid of excess water through transpiration. Then the trees shed off their leaves at different intervals as they fully mature. Then they the trees of hardwood tree species being in tropics, and because they take long to mature, and due to constant high temperatures. Then they have short stammy trunks. So the trunks are short and tilted kind of with aerial roots. Why? Because now the conditions why that way, because they have to breathe. So God created them in that feature to enable them breathe. Then they grow parallel to the coast due to constant silting. Waves tend to blow silt parallel to the coast, which attract them to grow. Then the trees are umbrella shaped and they tend to develop close to the ground. They have a long gestation period of 30 to 40 years due to the harsh tropical climate conditions, which do not favor faster growth. Then they contain hydrophytes. These are trees which love water, so water-loving plants. Then they are associated with gray leathery foliage, and they tend to appear on water. So we're done with the characteristics. Then you go to the factors. So you have to put a statement, say, the following are the factors which favor the growth and distribution of mangrove vegetation along the coast of East Africa. So if you look at that, so we look at the conditions. Yes, Koja. Yes, Koja. Koja, I can ask. Which type of vegetation is found in northern Kenya? Of course, you know, northern Kenya has semi-desert, which is the same as dry bush savanna. So if they say account for the growth of semi-arid vegetation, you can use the information of semi or dry savanna to answer that. Natural vegetation distribution, okay. I'll hint about, okay. Now, let me first finish this, then I'll hint about that question. Now, we look at the factors. They can say to what extent is climate responsible for the growth and distribution of mangrove forests. So when they say to what extent does climate influence, of course, you start by locating, give us all the characteristics, state the extent, give the role of climate, give the role of other factors. So climate divided into three. Rainfall of over 1,500 millimeters, which is fairly distributed, favor the growth of, bringing the, just speaking a characteristic, evergreen mangrove tree species. High humidity of over 80%, leading to heavy rainfall for proper growth of trees that are evergreen throughout the year. Hot temperatures of over 24 to 30 degrees, leading to the growth of luxuriant. Then when you're done with climate, you go to soil. Soil, 2 points. We have impervious clay and peat soils, and core soils which do not allow water to percolate through, but stagnate, favors the growth of mangrove. Then shallow, salty waters, which allow the growth of shrubs. Someone is asking, of course, when you're giving your introduction, you need the location. where they are located. So don't forget that. So you look at the altitude. Of course, they are located at a very low altitude of below 200 meters above sea level, because now this kind of altitude is associated with the hot temperatures and heavy rainfall. Of course, the low altitude also favor the accumulation of silt, mud, and alluvial soils. Then you talk about moment. So you talk about relief. Of course, they grow in the coastal, lowlands, and broad valleys where accumulation of silt occurs. Then drainage, they only grow in poorly drained areas. So you can only find them in soggy, waterlogged areas. Then latitude, they grow between 5 degrees north and south of the equator, because there it is associated with very hot temperatures, which hot temperatures favor the growth of these. Then they are also helped by the presence of coral reefs, which block strong waves and tides from blowing them away. Then lastly, supportive government policy, which favors the conservation. But however, where man encroaches on it, it is fading away. Now, how do I attempt questions of what extent in relation to any? Now, if the question is to what extent, that means that question is a two-sided question. For example, they can ask you a question, to what extent does the nature of the parent rock or rock lithology influence the rate and nature of weathering? Is it okay? Or the rate and nature of, let's say, physical weathering. Of course, because the question is direct physical weathering, you define physical weathering, identify and describe the physical weathering processes. Then when you're done with that, evaluate the question, what extent? You say to a large extent, the nature of the parent rock influences the nature and rate of physical weathering, as can be analyzed in the following ways. So you talk about rock hardness, rock color, but either way, hard rocks, soft rocks. Then when you're done with the nature of the parent rock, go to the other side. You say, however, other factors also influence. Then you bring in relief, climate, time, and the thing is done. Do you first talk about the growth of mangrove vegetation, they explain the types of? No. The question is clear. The mangrove vegetation is one. You don't talk about other types of mangrove. It is just one. The cases where you have three types of vegetation is swamp vegetation, where you have mangrove swamps, grassland swamps, and the papyrus swamps. Then mountain vegetation, where you have heath and moorland, temperate, and bamboo. But for Mediterranean and mangrove, for Mediterranean and which other one? Mangrove, it is just one. Now, let me comment about vegetation on altitude. Now, when they say vegetation on altitude, that means you get a mountain. Of course, you define natural vegetation. Then you say you get a mountain, you draw that diagram where you have a mountain and you show the height. You begin with the savanna, then tropical rainforest, then you go to savanna and other savanna. Of course, you have savanna, dry grassland, woodland. Then you go to forest, tropical rainforest. Then from tropical rainforest, you go to temperate. Then from temperate, you go to bamboo. Then from bamboo, now you have to show us that between this height and this height, we have this vegetation characterized by, you can give like 4 characteristics. You give the factors why it grows at, for example, if they say what extent? They can say with reference to any one mountain, explain the influence of altitude, explain the extent, to explain the influence of altitude on vegetation distribution. So you identify the height, give us the, between this altitude and this altitude, you have this vegetation. With these characteristics, it grows there because of these factors. Then above that height, we have this vegetation. With these characteristics, it grows there because of these factors. But if the question says, to what extent does altitude influence the vegetation of distribution? Once the number has vegetation distribution, it's a very wide number. It requires you to define vegetation, natural vegetation. Then you identify the various types, but don't go into too much details. You can give three characteristics or 4. So you say, we have equatorial forests. Located, give us the areas, give us 4 characteristics. Then you also have savanna vegetation. You give us, subdivide into 3. Dry savanna, give us where it is located, 2 or 3 characteristics. Then you go to savanna grassland, where it is located, 3 characteristics. Go to woodland, where it is located, 3 characteristics. Then go to swamp, mangrove swamp, where it is located, papyrus swamp, some few characteristics. Then when you're done with that, because the question is about natural vegetation, then you give one factor. For example, you're explaining climate. When you explain climate, explain that factor in terms of all the vegetation types. For example, you say heavy rainfall of over 1,500 millimeters, which is evenly distributed throughout the year, lead to the growth of equatorial rainforests with the evergreen trees, for example, mahogany, etc. Then moderate rainfall of around 750 to this is the growth of, you talk about the woodland. Then you keep going down. So you talk about one factor in terms of all the other vegetation types. Then you go to another factor, that is distribution. Do you first talk about the growth of this one I explained? Yes, Hope integrated. You can ask your question, Hope.
Still on questions that to what extent? I was told that this question.
Okay, get me one question of your choice.
What item given in the question? For example,
which topic? Okay, tell me.
What extent? Like mass wasting.
Okay, they can say, okay, so use landslide. Okay.
Has climate influenced the rate of?
To what extent has climate influenced the occurrence of mass wasting or landslides? Okay, let me talk about landslides. Okay. So to what extent is climate responsible for the occurrence of landslides in East Africa? Are you getting it? Define your landslides. Then identify the types of landslides. Identify and describe the different types of landslides. Are you together? For example, landslides are fast movements. So you talk about rock fall, rock slide, rock slump, avalanche. You describe them. Are you together? After describing them very well with the illustrations, then you state the extent. It is up to you to say to a larger extent, to a small extent, there's no problem. So you say to a larger extent or to a small extent, climate influences the occurrence of landslides in the following ways. Now, which factors are under climate? Talk about heavy rainfall. What does it do? It leads to the pounding effects, which creates vibrations, leading to, don't mention landslides or mass wasting, leading to bringing the processes, leading to rock slide, rock fall. Are you together? Then you look at heavy rainfall also reduces the friction and adds on the weight, leading to bringing the processes. Then you talk about very hot temperature, very cold temperatures in mountainous areas lead to freeze and thawing, which lead to high rates of. So you talk about all factors under climate. When you're done with climate, you also talk about alternate heating and which lead to expansion and leading to rockfall. When you're done with factors under climate, then you say, however, there are other factors. Now bring in other factors and explain them very well. I hope I've answered your question. Then Vanunji, you can also ask your question if I continue. Someone asked about, there's a question, let me see. There's a question. Environmental lapse rate and saturated lapse rate. Now, you need to know that we have lapse rate as atmospheric conditions where you have the higher you go, the cooler it becomes. Now, what environmental lapse rate and saturated, when you say saturated, it means there is some bit of moisture. The air that is rising has moisture, whereas the other one is dry. It is the temperatures are cooling because of it is dry but cold. Are you together? This one is dry and moist. So that's the difference, but they are almost the same. Ask more questions. Effects. Oh, okay. This one is very easy. Examine the causes and effects. I think let me leave other questions and I go through your questions. So, examine the causes of sea level changes. That is the easiest question. What are sea level changes? Sea level changes refers to a rise or fall in the level of the sea in relation to the land. Are you together? Then you tell us, we have two types of sea level changes. We have a positive change, which is also referred to as a rise, which is also referred to as, let me use, so a positive change, which is also referred to as a rise, which is also referred to as submergence. So where there is our rise in the level of the sea, it leads to the coasts, along the coast, submerge. They are covered by water. So that's why we say rise, positive change, submergence. Now we have two types of a rise. Two types. One is, you say, when a sea level rises in relation to a highland area. Can you put the screen? And they see? Let me see. Let me explain this one. Make it so that they can see on the board. I want you to see directly. Okay. So, examine the causes and effects of sea level changes. It's also referred to as eustatism. So the question requires you to define sea level changes. You give us the types, so you define, you talk about the types. Then after the types, you give us the causes. Then you give us the effects. Now the effects are the landforms. The effects are the landforms. So what is sea level changes? It is just a rise or fall in the level of the sea in relation to land. That is sea level changes. Now we have two types of sea level changes. We have what we call a positive change. We have what we call a positive change. A positive change is the same as a rise. It is also referred to as submergence. It is also referred to as sea transgression. It's also referred to as sea transgression. It is also referred to as sea transgression. Now, we say, when you're defining this one, it refers to just a rise in the level of the sea in relation to land. So where the water level rises in relation to land, that's what we call a positive change. Now you said there are two types. So under a rise, you have two types. So you say if you say where a rise in a sea level in relation to highland coasts. In relation to highland coasts, they say if the level of the sea rises and the neighboring area is a highland, it leads to the formation. It leads to the formation of submerged highland coasts. This is the formation of submerged highland coasts. So if our water level rises, we're looking at under positive change, you have two types. We have a rise in the sea level in relation to a highland coast. So the resultant feature are highland submerged coast. If where we have a rise in a sea level in relation to low land coasts, we have the formation of it leads to formation of so this highland, no, this is no in relation to this formation of okay in relation to lowland coast, yes. This is the formation of submerged lowland coasts. In other words, if the water level rises and the neighboring area is a highland, then the coastal features around will be covered by water. So we shall have part of the highland covered by the water. That's why we say submerged highland coast. But if the water level rises and the neighboring area is a lowland, then the lowland, part of the lowland will be covered. So we shall have formation of submerged lowland coast. That is under a positive change. Then we go to the next one. The next one now is a fall in the sea level. This is also called negative change. It is also referred to as sea regression. They can ask you a question, distinguish between sea regression and sea transgression. So as you hear those terms, yes? Someone is asking when answering. Okay, to be fast finish this. Then, so a fall in the sea level or negative change or sea regression. Now, this one, the same thing. A fall in the sea level in relation to highland coasts. If there is a fall in the level of the sea in relation to highland coasts, what happens? We have the formation of, now when the sea level falls, what was covered emerges out. So it leads to formation of emerged highland coasts. Then, where there is a fall in the sea level in relation to lowland coasts, we have the formation of it leads to emerged lowland coast. So once you know this, then the topic is very easy. So to summarize, I said we have a rise in the sea, a rise. We have eustatic. This topic is called eustatism, or sea level changes, which refers to a rise or fall in the level of the sea in relation to land. So we have two types of sea level changes. We have a rise, which is also called a positive change, which is also called sea transgression, which is also called, it's also called marine transgression. Then you also have a fall, which is also called negative change, sea regression, etc. Now, under a rise, you have to, if it happens near a coast, which is a highland, it's to the formation of submerged highland coasts. If it happens near a coast, which is a lowland, this is the formation of submerged lowland coasts. Then you go to a fall. If it happens in the highlands that are lowland, you have the, now, when the water level goes down, what was covered emerges. So you have the formation of emerged lowland coasts. When the water level goes down, when the water level rises and the coast is a highland, you have the formation of emerged highland coasts. Now, when we are done with this, we go to the causes of sea level changes. Causes of the sea level changes. Now, these ones are very easy. If you know this introduction, and you know the causes are very easy. You don't need to even strain so much. So the causes, now because we are catering for two things, the points are going to be like this. So the first point is climate. Under climate, we have pluviotion, which is the same as prolonged heavy rainfall. So the points you said, pluviotion and the desiccation. Desiccation is the same as long droughts. So there are 2 points, and we're going to answer them concurrently. So where we have prolonged heavy rainfall, what happens? It leads to a rise in the level of the sea. Whereas where you have a long drought, we tend to experience high rates of evaporation, leading to a fall in the level of the sea in relation to land. Make sure you don't forget that. A fall in the level of the sea in relation to the land. Then you go to another point, which is hot temperatures. Hot temperatures. Now, hot temperatures do two things. Of course, under hot temperatures, we have high rates of evaporation. High rates of evaporation from water bodies lead to a fall in the level of the sea, whereas expansion of water molecules leads to an increase in the level of the sea. Hence, then you talk about glaciation and deglaciation. Deglaciation. Where glaciation occurs, it means water freezes, and rivers cannot flow from the mountainous areas to water bodies. So where I have glaciation, it means water is locked up in form of ice. So in such areas where I have a lot of glaciation, the water level goes down. Then where I have melting of snow, which is deglaciation, it means a lot of water. For example, if you look at River Nyamwamba, when water melts from the tops of Mount Rwenzori, that water flows, and this will arise in the level of the sea. Then, so here you can have a question: to what extent is climate? What extent is climate responsible? What extent is climate responsible for the occurrence of sea level changes in East Africa? What extent is climate responsible for the occurrence of sea level changes in East Africa? So once they ask that question, give us that introduction I gave you, give us the extent, give us all the causes. Now, when you're done with the climate, you go to other, we also have earth movements. Earth movements. So they can also ask the question, to what extent are earth movements responsible for the occurrence of sea level changes in East Africa? So under earth movements, you talk about warping. And under warping, you have to talk about, to give us two answers. We have, the first one is upwarping of the coastal areas and downwarping of the coastal basin. So upwarping of the coastal areas and the downwarping of the and downwarping of the ocean basin leads to a rise in the sea level. So where the coast is being uplifted and the basin is being downlifted, automatically the water level will go down. Then where the coastal basin is being uplifted and the coastal areas are being, where there is upwarping of the coast of the basin and downwarping of the coastal area, of course, we shall have a rise in the level of the sea. Hope I'm clear there. Yes, someone is asking. So you give the causes. The causes, you know them. Seems you know the causes. Now the landforms, since you know the causes, let me go to the landforms now. Is it so?
So we are requesting you to clarify whether we should draw the map or not on the when we are describing about soil erosion? Are we supposed to draw the map of East Africa or not?
No, you don't draw.
Okay.
You don't draw. Any other question if I continue?
No.
Okay. So it seems you people know the causes. Let me go to the landforms. Are you okay with the causes of sea level changes? Okay. Yes? They're okay. You okay? Okay. So let's go to the landforms. Now, the landforms we have now here. We have landforms resulting from a rise in the sea level. So you have landforms resulting from a rise in the sea level. Now we have what we call a rise in highland area, and you also have a rise in lowland area. So now, where we have a rise, we have two landforms and land them. They are the same, but what makes them different is where they form. So you have two landforms now. The first one is area, and this one is called Ani estuary. Are you getting it? They are exactly the same. The only difference is that this is a drowned river valley in a highland area. This one is a drowned river valley in a lowland area. So this one is where you have a river entering the sea. Then what happens? The sea level rises. Then the water enters the mouth of the river. So when you explain the formation, you say area is formed due to a rise in the level of the sea, and it drowns the mouth of the river in a highland area. And as an estuary is formed due to a rise in the level of the sea in a lowland area and drowns the river valley. So this one, rise, drowning of a river valley in a highland area. In this one, rising and drowning of a river valley in a lowland area. But they're the same. They're all drowned the river mouth. I guess the point is taken. So when you're drawing, so how are they formed? They are formed due to a rise in the level of the sea in you can even say relation to low land area, hence drowning the river mouth. So when you're drawing, you draw, the diagrams are almost the same. The diagrams are almost the same. The diagrams, this one is like this. Then you draw your area like this. So it's the drowned river valley. You draw this. It's the sea. This is now highland. So you put this as area. Then here you draw the same thing. Are you getting? Exactly the same thing. C. Then you put this as, this is a lowland now. Now this is now an estuary. So I think that is clear. Or you can't see. I'm sorry about that. Now, if you can't see, let me try to put light. Can you see now? Okay, let's leave that. So then we have another landform is called a field. A field. A field. A field is like this. Like you say, when you're dealing with the questions of fishing, you say fielded coastlines. Fielded coastlines, eh? Now, a field is where you have a mountain, and this mountain, there's a river which moves from the mountain, and it pours its water into the sea. But before the river formed in that valley, ice used to move from the mountains into the sea, and that ice, through the process of plucking, dug a very deep valley from the mountain for kilometers and comes and pours its water into the sea. Now what happens? The sea level rises and the water of the lake enters into that valley for several kilometers. That's what we call a field. Then you also have, unfortunately, I can't. Okay, let me see how I can help you. I can't, this is on this, okay. I'll post those notes. So you have what we call longitudinal coastlines. Longitudinal coastline is where you have, you said you can't see the board. Now I don't know what to say. I can only... Huh? I don't know, because now these issues need explaining, and you said you can't... Okay. Okay. So,
First right around here.
So we have what we call longitudinal coastline. They're also called Dalmatians. Dalmatians. Now here we have a coast in this format. You have this as your lake. Then there are hills that are running parallel to the lake like that. So this is one hill, this is another hill, this is the third hill. And these hills are separated by these valleys. Okay? There are valleys. Now this is the sea. Now what happens? There is a river which cuts through these mountains and pours its water into the sea. Now what happens? When the water level rises, this sea will look like this. Because the water is so strong, this water will hit these mountains and they will die away. And we shall have this with small islands. And this water body is what we call a sound. So what happens? Initially, we had islands which were prior to the sea. And there was a river which was coming from the mountains into the sea. Now, when the water level rose, this water went and hit these islands and they were broken. And we had islands and this kind of a landscape. That's what we call a Dalmatian coast or coastline. I guess that one is very clear. Then you talk about a peninsula. A peninsula like Entebbe Peninsula, where you have land, but this land is raised, and this land has valleys, and is facing the water body. When the water body rises, the valleys will be filled up and land will remain rising as like that. Then when you go to the other side of the Valley coastlines, emergence or negative change. You talk about raised. These are very easy, you can read. So what was covered? What was covered by water? As the water level recedes, what was covered emerges out. That's why I have raised details with raised wave platforms, and the question is done. The question is done. So you can revise about it. You can revise about it. So soil. This is the easiest topic. But they're telling me to talk about it. Now, a soil profile. Do you have a flash there? Okay, let me see what I can do for you. My name is Ondoroma Gilbert from. Could you help me with your number, as I would like to invite you to come and help my learners? Okay, my number. How do I put it? Okay. Look for final book. Okay, I'm getting for you notes on soil profile. But soil is the easiest topic, so don't fear, you'll pass it. So all of you get a book, get a paper, draw for me something like, and divide it into 4, but make sure the first part is big. So draw something like this, and the first part you draw it into 4. You draw it into 4 parts: A, B, C, D. Can you do that for me as we wait for the notes? So you draw vertical, draw like this and this. Then you draw 1, 2, 3, 4. So you put a big A, B, C, D. Are we done? Now, we look at A. We start with A. Now, A, you're going to make a small layer on A, like a first one, and you put that as AOO. Is it okay? And right there, undecomposed organic matter. Undecomposed organic matter. That's the first layer. Then we have AO. That's the second layer. Can save this. But it is big. Can you just pick out soil? Scroll until you read soil. We have A. We have AO, which is made up of the first one is undecomposed organic matter. Then we have AO, which is made up of decomposing organic matter. Sorry about that. So the second one is decomposing organic matter. That is AO. Then the second layer is A1. A1, which is made up of a dark layer of humus. A dark layer of humus. Then we have A2. A2 is made up of a light color zone due to maximum leaching. A light color zone due to maximum leaching. Then we go to A. I said A1, then A2. That is a transition zone. At the transition zone. Now we go to B. Are we together, people? We go to B. We have B1, which is a transition zone. Which is a transition zone. Then we have B2, which is a dark layer. A dark layer due to leaching and eluviation. Eluviation with a dark layer due to, are we there? A dark layer due to accumulation of leached and eluviated material. Accumulation of leached and eluviated material. Are we there? Then we have B3, which is a transition zone. B3, which is a transition zone. Then we go to C. I'm going to give you this, don't worry. C, which is also made up of partially weathered rock material. Partially weathered rock material. Then lastly, we go to D. So we have A subdivided into sublayers. AOO made up of undecomposed litter, followed by AO, which is made up of decomposing organic matter, which is followed by A1, which is made up of a dark layer full of humus, which is followed by A2, which is made up of a light color zone due to leaching. A1 is followed by A2, which is a transition zone from A to B. Then you go to B. B is made up of 3 layers. B1, which is a transition zone from A to B. Then B2, which is a dark layer made up of eluviated and leached materials. Then you go to B3, which is a transition zone. Then you go to C, which is made up of partially weathered rock material. Then lastly, you go to D, parent rock. Now, they can say, to what extent, write for me that question. To what extent, now, wait. Now, after drawing that, you have to define a soil profile. A soil profile is a vertical arrangement of soil layers. Vertical arrangement of soil layers from the top soil to the bottom, to the subsoil or to the parent rock. And these layers are subdivided into A, B, C, D. And these layers can be differentiated by their colors, texture. Then after defining like that, you draw, then you describe what you're saying. From A, you mention those layers. Then when you're done, you write this question for me. To what extent does the nature of the parent rock, to what extent does the nature of the parent rock influence the development of a soil profile? To what extent does the nature of the parent rock influence the development of the soil profile? Give me 2 minutes. Influence the development of a soil profile. Now, do for me one thing, outline the nature of the parent rock. The first nature is rock hardness. Are we there? Rock hardness. The second nature is rock permeability. The second nature is rock color. Mineralogical composition, age of the rock, rock texture, rock texture. So we start now. We're looking at the different natures. Okay. Now, the factors of soil profile development are the same factors of soil formation. The only difference is that where there is soil, you end at soil. Where there is soil profile, you continue and go an extra mile and talk about. So, for example, nature of the rock, hardy parent rocks. Are you getting it? Now, under rock hardness, hardy parent rocks can easily be broken down by both physical and chemical weathering. Can easily be broken down by both physical and chemical weathering, leading to the formation of well-developed deep mature soils. Hence, well-developed soil profile. Let me repeat. No, I made a mistake, sorry. Hardy parent rocks cannot be easily broken down by both physical and chemical weathering. So they lead to the formation of shallow, immature soils, and therefore poorly developed soil profile. On the other hand, soft parent rocks can easily be broken down by both chemical and physical weathering, leading to the formation of well-developed deep mature soils, hence well-developed deep mature soil profiles. Are we there? Then we go to rock permeability. Are you there? Permeable rocks allow water to percolate through them. Permeable rocks allow water to percolate through them. Hence, can easily be broken down by both chemical and physical weathering, leading to formation of well-developed deep mature soils. Hence, the formation of well-developed soil profile. So then you go to rock color. Dark-colored rocks can easily be broken down by physical weathering process of thermal expansion. Hence can easily break down to form deep mature soils, hence will develop deep mature soils, soil profiles. Then you go to rock, which other Navantai talked about, mineral compositions. Okay, let me project there. It's hard to explain like this. I want you to be seeing such that, have you saved it? So we're going to, okay, that's now put it here, export it. So soil is the easiest topic. You have to get 25 out of 25. Now, can you put the other like we are doing? Okay. So there we are. It's not moving. like this. Okay, let's go to what we're talking about. This is what I was talking about. Hope you can see that's the soil profile. But make sure you put it in between the line, not along the line. AO should be in the first box. AO should be in the second box. I don't want you to put them along the line, so try to do it properly. So that's my soil profile. So if you're defining, I don't know, are they seeing? Okay. If you're defining, that information is very important. That's how we define soil profile. So those of you can access my book. I have a book. This is part of it. So it is composed of soil layers. You define like that. Then you do that. Then after that, you draw. After drawing, you describe what you've drawn. Now you describe from our developed soil profile is made up of 4 layers, A, B, C, D. Horizon A is made up of, so you explain what you've drawn. After that, now you go to, we're looking at the nature of the parent rock. Now those are the factors. Now you see, that's the nature of the parent rock. So you see hard rocks. We look at hard rocks and we explain them concurrently. Hard rocks like granite are not easily broken down, leading to thin soils and poor developed soil profile. Now, these are the same factors for soil formation. So, whereas soft rocks like clay can easily be weathered, leading to the development of well-developed soil profile. Then you go to rock joints like that. That's how they are explained. I guess you have them. Then when you're done with the nature of the parent rock, like that, then you go to other factors. Now, other factors, they can also ask a question, to what extent is climate responsible for the formation? Or you can say, climate is largely responsible for the formation of soil profile. Discuss. So you bring in climate. Now, you divide climate into different climatic regions. We have equatorial climate. Let's pass this one. Okay, we shall talk about the numbers. Now, if they say describe the characteristics of the soil profile, you define, draw, describe. Describe everything you see, then you got the factors. So that is climate. They're still growing, okay. But come, it's not scrolling. Come and help me. They're still drawing, sorry about that. So, when they say describe the characteristics of a soil profile, that's what you should do. Define the 2 definitions that you saw there. Draw it very well. When you're done with the drawing, you describe. A well-developed soil profile is made up of 4 layers. A, horizon, which is subdivided into AOO, which is made up of undecomposed litter. AO, which is made up of decomposing organic matter. A1, which is a high humus content. A2, like that, okay? Then when you're done, describe, then go to the factors. Now, the same factors of soil formation are the same factors of, maybe what I forgot to tell you is that when they say soil types, when they say soil types, they mean zonal as zonal, intrazonal. So they can say account for the formation of the different soil types. Please don't talk about soil. It's about soil types. So you describe the different soil types, but the factors are the same. The number, you get it, and this book is there if you want it. You can ask for a copy. It's a very big book. It covers all the topics. You can go through this teacher who linked you here, and we produce on order. So I don't know whether you're done drawing. If you're done drawing, you send me a message and we go to something else. So the factors, make sure when you're dealing with the soil, you bring out the soil characteristics leading to the development of well-developed deep mature soils, leading to the development of poorly developed soils. If you're dealing with soil profile, leading to the development of well-developed deep mature soil profiles. Now, rock texture, you talk about, usually rock texture, they talk about roughness, and either the rocks are rough or rugged. If they are rugged, they allow water to collect on them. When they collect on them, that facilitates chemical weathering. And once it facilitates chemical weathering, rocks can easily be broken down. But rocks with a smooth texture, they don't allow water to collect on them. Then you also talk about texture in terms of particles. We have rocks with big particles, which call coarse-grained, cannot easily be broken down. Then you also have fine-grained, meaning rocks of small texture. The books, I don't have them. I produce on order, so the cover you'll see, don't worry. It's a big book. We shall talk about that. Let's first finish. Are you done drawing? I want to go to something else. So send me a message. Send me a message and send me a message. Send me a message and are they done? Okay. So I think it's not scrolling. Let me see.
How can we attempt the questions of ourselves?
How can we attempt the questions of assess? Now, questions of assess, it depends on the paper. If the paper is, oh, they still want 2 minutes. Okay, to me, but you're so slow. Questions of assess, it depends. They can say assess the influence of volcanicity on the formation of landforms. But assess usually comes in coral reefs. When they say assess the relevance of Darwinist theory, that means when they say relevance, numbers of coral reefs, you begin by defining, give us the process of formation, give us the types, conditions, all numbers of coral reefs, you have to give those ones. Then when the question is about assessing the relevance, state the theory. After stating the theory, give its relevance and criticism, end there. But if they say assess the role of Darwin theory in explaining in the understanding of the formation of coral reefs, define coral reefs, give their process, how they form, give the types, conditions, state Darwin theory, evaluate the question, state other theory. But if it is assessing in paper 2, you give your introduction, give the positive importances. When you're done, write another statement. However, the negative, talk about the negative importance. Maybe you can ask questions. The rest we shall meet next time. I want questions now only. So it's open. About the phone number. Where do I put it? Okay, the phone number. Where do I write it? All right. Okay.
Schools that have questions, kindly.
Yes. Yes, I can't hear you. Drainage on which topic? You repeat your question, I didn't get it. That's my contact. We have other Zoom. So let's see the coordinator talk about that. So you've seen my numbers. I have textbooks. I have a very nice textbook. It has question and answer. Unfortunately, I produce on order. So you can types of discordant drainage pattern. Oh God.
You are Adit, you can unmute.
Yes.
You are Adit, it seems you have a question. Kindly unmute.
So now the other question, I have all those things are in my books. We shall discuss them maybe another time. I have so many questions, but anyway, about drainage patterns, I can briefly see. Because we have those ones that are determined by the nature of the slope, and those ones that are determined by where there are no relationship between the nature of the slope and so there is no relationship between the nature of the slope and let me see how I can help you. So you want the definition. I want to give you the real definition so that you copy and you have it. Yes?
Hello.
Hello?
Hello.
Yes, talk.
Yeah, thank you very much, sir, for the facilitation.
Yes, please.
For me, we just want you to help us tell us about, like when they have asked for problems, how we can identify them from the map extract and the photograph.
Okay.
Thank you.
Let me begin with the map extract. You look at the map extract and you look at the features that are there, okay? You look at the drainage, you look at the swamps, you look at the water bodies, and you study the contours to see whether there are mountains and what. Now, you get if there are mountains, you give problems of mountains and you give evidence by mentioning the hills, the ridges, and the name of a place and direction. If there is a water body, you can talk about drowning of people. You give the water body as evidence. You can talk about breeding ground for pests and diseases. You mentioned, for example, Lake Nachi Valley as evidence. Now, when it comes to photographic interpretation, by the photographic interpretation, you have two types of photographs. You have aerial photographs and the ground photographs. Now, aerial photographs, we use top, bottom, center. Don't use ground. So you say top, bottom, center. Then ground photograph, we use ground. We use foreground, background, and middle ground. Now, if you're coming up with problem, look at the photograph. Is there a mountain? Then if there's a mountain, look at the problems associated with the mountain. For example, landslides. And the evidence are the steep slopes in the background. Soil erosion, the evidence steep slopes in the background. Are you getting it? Well, if there is a water body, then you will be referring to water body in the foreground as evidence. Another question? Can I get questions? Yes, there's this one who sent. Can we see the book cover? Book covers. Oh, it's not here, but I'll get it for you. but they are not in the bookshop, because in the bookshop, they duplicate them. So that's why you manufacture on order. So now, someone was asking about the rivers, drainage patterns, but those ones need when I'm explaining, because I can't explain without, so maybe next time I'll begin with those ones. When is the next geo class? We shall know that. How much is the book? The book is big. It covers physical geography. It covers climate, the whole of climate. It covers soil, so it's a big, and it has colored pictures. So it is sold at 30. 30? 30, yes. Ask. I have 5 minutes. Ask, but thank you for being good audience. Ask, yes?
So I'm back. The next question is how to find the types of drainage patterns on the map extract.
Oh, that's very good. Now, the first one is, okay, now do this for me. Draw a circle. Have you drawn it? Now draw 2 rivers moving from that circle outwards and put arrows. That if you see contours in a circular form, but yes. If you see contours in a circular form, but with the arrows moving in different directions, that is radial drainage patterns. Then if you have a swamp area and you see arrows pouring, like rivers pouring their water in a swamp area, that is centripetal. Where you have rivers and you see tributaries joining at right angle, that is trellis or trellised drainage pattern. Where you see a river and the tributaries are hooked, that is hooked drainage pattern. Where you see 2 rivers flowing in the same direction, that is spiral drainage pattern. Where can we find the books? You've gotten my number. You can call, you can talk to your teacher and they deliver, but I don't produce one. So we produce, because producing one is very expensive. So it's a matter of organizing for those who want. Then I produce, we can put them on the bus. The books, you can, the number is there. You can call and get the books, but we produce on order. 2 more questions.
I think.
Yes.
Skyline, that's the question.
2 more questions, please, people.
Skyland, ask.
Yes. Yes.
I would wish you to clarify about map enlargement and map reduction plus exaggeration.
Okay. I'm going to be very fast. Now, map enlargement. If they tell you to enlarge, let me begin by reduction. They can tell you to enlarge by 50%. Is it okay? Or any percentage. Is it okay? Measure the width and length of the map. Get that distance. So you get, let's say 50 out of 100 times that distance. Is it okay? Draw that distance. Then also for the width, 50 out of 100 times, then draw that. Then you also measure the lines that are thick inside. You also put them out of percentage, you put them there. Then when they give you a new scale, are you listening? Yes. For example, they give you a new scale as 1 to, you stay online, I want to hear, you want to communicate with you. When they say given a new scale as 1 to 125,000, enlarge. So you first get the scale factor. So you say scale factor is equal to old scale over new scale. So the old scale is found on the map. The new scale is the new one given. So get the answer, use that to reduce the map. Are we together?
Yes.
Even if they say reduce by 30%, say 30% out of. Now, enlargement, they give you between eastings and northing. So the first thing is to identify the area they want. That's say between this easting and between this northing. Are we together? So first identify that place. If they say enlarge by a percentage, let's say 50%, is it okay? Just measure that car distance. For example, if the distance is 60%, you say no, it's the distance is 6%. Say 50 out of 100 times 6. You get 3. Now get that 3, add it on 6 to get that distance, to draw that distance. Then you go to this one. If let's say it is 8, so you say 50 out of 100 times 8, you get 4. So get 4 plus 8, draw that distance. Are you getting me?
Yes.
Have you gotten me?
Yes.
Have you gotten me?
Yes. Yes.
No. Okay. Then maybe we'll get time. So thank you for being good audience.
Map exaggeration.
To exaggerate. Okay, to exaggerate. Exaggeration is for a cross section. So how do you exaggerate? Now, if you have your cross section and your vertical scale, right, vertical scale. If you're adding 50-50, is it okay? Yes. When you're drawing your vertical scale, I want you to respond, So you have 1 centimeter represent 50 feet. Now, how do you exaggerate? Now, to exaggerate, the formula is vertical scale over horizontal scale. Is it okay?
Yes.
Now you get your 1 centimeter represent 50 feet over the horizontal scale is 150,000, right?
Yes.
Now you have to convert the centimeters into, the feet into centimeters. Are you together? So you say 1, 2, get the 50 feet times. Now, if the units are in feet, multiply by 30. If the units are in meters, multiply by 100. Are you together?
Yes.
Is it okay? Now convert the vertical scale such that you get an answer like 1 to 3,000 over 1 to 50,000. Is it okay?
Yes.
Now, you divide. Now the answer you get, don't put units and don't round off. It can be 5.333 times. That's the answer.
Okay, sir, thank you. We have gotten the content.
Okay, have a nice time.
Thank you.
Okay, now people from different schools, I'm glad to meet you. Maybe God willing, next time we will meet. But the books, they're very good and they are question and answer. So they're very good. If you get it, it will be very easy for you to pass. So people from, I don't know, community school, I don't know how to pronounce it. Stella Maris Insuve, Nansana, Edward, Hope Integrated, Skyland, which is in Lira. We'll meet again.
Okay, Teacher Godfrey.
Yes.
Also allow me to first thank you so much for the wonderful facilitation you have offered this afternoon.
You're welcome.
We are grateful. Thank you so much. Looking at that, I'm seeing all the children are really very happy, very grateful for the great service you have offered. Thank you so much. For those schools who may wish to reach out to Teacher Godfrey, we have shared the number and also we shall share it on the recording. This recording is going to be availed for those students who were left behind you are going to be able to access the recording such that you can be able to review the PowerPoint, access, and also learn more on the geography. In case you wish to access some of the materials, his books, kindly reach out to him. He can be able to print and then your respective schools such that you can be able to access all the materials and everything he has been talking about. We shall request Teacher Godfrey, when time allows in the near future, before these children sit in for their exams, to come back and offer one final facilitation such that they go for their final examinations when they are very, very confident. But for now, let me just promise that maybe come third term, before you sit in for your final examination, when Teacher Godfrey has some space on his busy schedule, he can come back and he offer more facilitations. But Teacher Godfrey,
You're welcome. Okay, Bambi. Have a nice time.
Thank you. Bye. Thank you.
okay, thank you so much.